But once you get that value, what do you do with the value? That is what I shall be teaching you today. So today I'll be teaching you what exactly to do with the average titer value when you have it. Alright, WAEC is going to ask you, they can ask you questions on calculate the mass concentration, calculate the molar concentration of the acid, of the base, calculate the solubility, and all of that. So I want you to stick to this video to the end, and I'm going to show you how, step by step, how you can answer all of these questions. So before we continue, let me give you three basic formulas that you need to know if you will do well in your chemistry practical, which is your volumetric analysis. Without these three formulas, you cannot do well in that aspect of your chemistry. These are the three formulas. Go with me. No. If you have not subscribed to our channel, please do well to subscribe to our channel. These three formulas are very important. If you are going to do well in your volumetric analysis in chemistry, these three topics are essential for you. So for your volumetric analysis, which is also called your titration. Alright, so I take this again, number of moles, alright, equals to mass over molar mass. Number of moles equals molar concentration times volume. Alright, the unit of your number of moles is mole, the unit of your molar concentration is mole per dm³, the unit of volume is dm³. And this is shortened as M equals CV. And the third one, molar concentration equals to mass concentration over molar mass. So if you look at your question, if you check your past questions every year, they will always ask you, calculate the molar concentration of either A or B or both. Calculate the mass concentration of A or B or both. Alright, this is the formula you are going to use. So the molar concentration, the formula for molar concentration is mole per dm³. The formula for mass concentration is gram per dm, or the SI unit, sorry. SI unit is gram per dm³, and for your molar mass is gram per mole. Now, mind you, if you are answering any of the questions in your chemistry practical, you need to state the formula you are using. In your marking scheme, in the marking scheme for WAEC, there is something called the scoring point. Scoring points are those points that the examiner wants to see that will earn you or fetch you your mark. So, if the formula that is correctly stated will give you a mark, and then when you solve correctly, you get a mark, and then when your final answer, you get a mark. When you get the correct SI unit, you also get marks. So, all of these marks are very important. So you need to know the SI unit of all of these, and then you need to state them before using them. So these two are the major formulas you'll be using for your titration. I'm going to put some questions on the board, and I can assure you, guarantee you, that you are going to see a question like this in your volumetric analysis. Now, let's look at the typical question that you could be asked in your chemistry practical. A is a solution containing 6.3 grams per dm³ of HNO3. This HNO3 is triazonitrifide acid. So this is the acid in your question. So they said A is a solution containing this, while B is a solution of sodium triazocarbonate 4, Na2CO3. The equation of the reaction is given, so you'll be given an equation. From your results and information provided above, calculate. So before this point, they would have told you, take this amount of acid of A, pour it into your burette, then you titrate it against this amount of your base. They will tell you to put this sodium triazocarbonate in your pipette, then you do all those titration. Now, the essence of all of that titration is to get one value, and that value is your average titer value. Okay, so if you have done your own titration correctly in your school, and then your other colleagues have done it, you will see that you will have similar average titer value. Okay, even your instructor can guide you as to how to get to that. But once you get your average titer value, what is the next thing you want to do? So you would have drawn the table. You draw the table, all right? The table for, if you have not seen the video, there's another video on how to draw your table, all right? But once you have drawn the table and you get the average volume of acid use, which is the volume average titer value, all right? That is the volume of acid use. So our first parameter, our VA, is going to be this average titer value, which is the volume of acid used, is going to be 20. The volume of your pipette used is the volume of base. So they will tell you that you can either use 20 cm cube or 25 cm cube. But whatever pipette you were given in your school, that is the one you have to use. So if you are giving 25, most schools will use 25 cm cube. And your teacher, your instructor, your chemistry instructor in your school would have written a report that we have provided pipette of 25 cm cube for these students. So that is what the examiner will grade you on. So whatever they use in your school, that is what you should use here as your volume 25 cm cube. So having done that, the question says the first calculate the concentration of B in mole per dm cube. There is no way we can calculate the concentration of B without first getting the concentration of A. But we were given this value. This is 6.3 grams per dm cube. If you look at the first set of formula I gave, the equation 3 says molar concentration equals to mass concentration over molar mass. The mass concentration, the unit is gram per dm cube. So this 6.3 gram per dm cube is the mass concentration of this acid. But you cannot use that mass concentration directly in your calculation. You have to convert it to molar concentration. So the first thing you want to do is mass concentration of A is equal to 6.3 grams per dm cube. Now once you've done that, if you look at that equation 3, it says molar concentration. So you have to state the equation you are going to use. So the equation says your molar concentration is equals to mass concentration over molar mass. This is mass concentration. I need to convert it to molar concentration. I need the molar mass. So you have to calculate the molar mass of HNO3. How do you calculate it? Hydrogen is 1, okay, plus nitrogen is 14. So they have given it to you. Can you see nitrogen is 14, the molar mass, plus oxygen is 16, but you have 3 moles of oxygen here. So it will be 3 into bracket 16, or 3 times 16. Alright? And at the end you are going to have 1 plus 14, that's 15 plus 48. And that will be 63 grams per mole. So that 63 is your molar mass. So you come back to this formula. So your molar concentration will now be equals to mass concentration, which is 6.3 divided by 63, which is the molar mass. And when you divide it, your answer is going to be 0.1 mole per dm cube. So you have succeeded in calculating the molar concentration of this acid. This is what you will now use to answer the first question, which is concentration of B in mole per dm cube. So what formula are you going to use to get this concentration of B? You use the equation 2 that I gave you, which is number of moles equals to molar concentration times volume, which is N equals Cv. So, and in this case, it's going to be written as Ca. So for our Roman figure 1, mind you, all of this would have attracted marks. You would have gotten some marks for this. So number 1, concentration of B. So to calculate the concentration of B in mole per dm cube, I'm going to do what? CAVA over CBVB equals to NA over NB. If you recall, that formula is number of mole equals molar concentration times volume, which is N equals Cv. So this is the same formula. So what you need to do is cross multiply and make your Cb the subject of formula. So when you cross multiply, you have CAVANB equals to CBVBNA. And then we divide both sides by VBNA so that CB can stand alone. VBNA, VBNA. So this cancels this, then your CB is now what? CAVANB over VBNA. So you impute the values. What's that? Ca, which is the molar concentration of the acid, 0.1, multiplied by what is Va? That is your average titer value, 22.60. Multiplied by what's the Na and Nb. So we have not stated our Na and Nb. So our Na from the balanced equation. So the equation you were given, all you need to do is to inspect the equation. Okay, this is the equation. You inspect it. How many moles of acid do we have here? It's 2. Can you see this 2? Okay, so 2 moles of acid. That means my Na is 2. And this is my base, is 1 from the balanced equation. My Nb is 1. Before you do that, please inspect this. So let's inspect it. Hydrogen is 2 here. Hydrogen is 2 on this side. Sodium is 2 here, sodium is 2 on this side. Nitrogen is 2 here, nitrogen is 2 on this side. Okay, oxygen here is 2 times 3, 6. 6 plus 3, 9. Oxygen here is 2 times 3, 6. Plus 2, 6, 7, 8, plus 1, 9. So this is a balanced equation. Therefore, our Na is 2, our Nb is 1. So you insert the value, Nb is 1. So times 1 divided by, what is our Vb? Our Vb is 25. Okay, 25 times, and what is our Na? Our Na is 2. So this is what you are expected to do. So if you punch this on your calculator, 0.1 multiplied by 22.60 times 1. So what will be your answer? So I think I can wipe this side. So when you punch this on your calculator, your Cb, which is the molar concentration of B, is going to be 0.0452 mole per dm cube. So you have succeeded in calculating the molar concentration of the base. That being said, the next question now says calculate the concentration of B in gram per dm cube. So our Roman figure 2, you were now asked to convert this molar concentration to grams per dm cube, which is the mass concentration. So the formula you will use is what? Your molar concentration, all right, is equals to mass concentration over molar mass. So what is the molar concentration? 0.0452 is equals to mass concentration, which is what we are looking for, x gram per dm cube, divided by what is the molar mass of our B. And you remember our B is sodium triisocarbonate 4, Na2CO3. So let's quickly calculate the molar mass. Na2CO3. Sodium is 2 moles of sodium here, and the molar mass of sodium is 23. So you are going to have 2 times 23 plus carbon is 12, all right, plus oxygen is 3 times 16. So this is 46 plus 12 plus 48. And that's this 60, 106 is going to give you 106. All right. So if the molar mass is 106 and formula says molar concentration is mass concentration over molar mass, you just put your 106 in and you cross multiply. So our x is going to be 0.0452 multiplied by 106. So if you punch that on your calculator, 4.79 grams per dm cube. That is the answer. Note, when you are calculating molar concentration, that's concentration in mole per dm cube, it will always be a small value, 0.1, okay, mole per dm cube. That is one way you can know if your calculation is correct or not. But when you are calculating mass concentration, 4.7, you can use it a bigger value. The molar concentration here was a small value, but here it's a bigger value. So this tells you that your answer is correct. Therefore, the mass concentration of B is 4.79 grams. The next question now says calculate the mass of sodium ions in 1.0 gram per dm cube of B. Calculate the mass of sodium ions in this. So number 3, if you look at your sodium triisocarbonate, if you ionize it, it will give you Na plus CO3 2 minus. But there are 2 moles of sodium here, so I'll put 2 here. So the implication of this, they are asking for the mass of sodium ions, so these ions, in 1 gram per dm cube. So all you just need to do, look for the molar concentration of this. And what was the molar concentration of B? It was 0.0452 mole per dm cube. Alright? So all I need to do, this is the molar concentration of this compound. If I ionize it, each ions will also have this same concentration. But because there are 2 moles of sodium here, this concentration of this will be 2 into bracket 0.0452. So I'll multiply this by 2. Mole per dm, this is in mole per dm cube. So I can get this mole per dm cube is the meaning of mole per dm cube means the amount of moles in 1 dm cube. So I can as well say this is the number of moles of sodium triisocarbonate. This is the number of moles of sodium ion. So I will just convert this number of moles to mass and I will get the mass of sodium ion. So how do I do that? So I'm going to have the number of moles of Na ions will be what? 0.0, this will be 4, 10, 8, 9, 0.0904, 0.09. Okay, that is the number of moles. But I was asked to find the mass. This will now bring us to the first formula I gave you. Remember, the first formula is number of moles equals mass over molar mass, and the molar mass of sodium is 23. Okay, so I'll just say number of moles equals to mass over molar mass. Therefore, equals to mass over molar mass is 23. So I'll cross multiply. So if I cross multiply, the mass of sodium ion will be 0.09 multiplied by 23. And if you multiply your 0.09 by 23, your answer is going to be 2.07. So our answer is going to be 2.07. 2.07 grams. The mass of sodium ion is 2.07 grams. That is the answer to the question. This particular compound, look out for it. Watch out. You might come across exactly this compound in your exam. I'm talking about HCl, hydrochloric acid, and the base, which is sodium triisocarbonate 4. And that is why you need to pay attention to this particular aspect of this video. Now, A is a solution. So this is a question, and they gave you a step-by-step guide as to what to titrate, what volume of this to titrate against what volume of this. But like I said in the first video, all of that are not included in this video. What I want you to understand in this video is how to do now. All I want you to understand in this video is how you can do all of these calculations, how you can answer all of these questions without stress. Is that okay? So we are going to assume that our theta value, so what are we going to use for our theta value for this particular question? So look at this. For this question, you have you were given these parameters: H equals 1, C equals 12, O equals 16 molar mass, sodium is 23, chlorine is 35.5. 35.5. Okay. Now, the equation given is Na2CO3 plus 2HCl. You have sodium chloride, H2O, and CO2. What are the questions we ask? So let's assume you would have calculated or you would have carried out the experiment in your school and you would have arrived at a particular titer value. Volume of acid used for this video is going to be 24.90 cm3. 24.90 cm3. And my volume of pipette use is going to be 25 cm3. So with this, we can actually have, this is our acid, this is our base, this is our A, this is our B. So our Na is going to be 2, Nb is going to be 1, because 1 mole, 2 moles of HCl, so Nb is 1. Then volume of A, that's our average titer value, is 24.90 cm3. Then the volume of B is 25 cm3. You state the parameters correctly and you get marks for it. So here, A is a solution containing 1.04 grams HCl per 500 cm3 of solution. So with this, we can determine the concentration of our acid, the molar concentration, with this information given. So for us to get the Ca, which is the molar concentration of the acid, we were told that 1.04 grams of the HCl was present per 500 cm cube. 500 cm cube, alright? So, and with this, we can calculate the mass concentration and we can now convert it to the molar concentration. And concentration, molar concentration or mass concentration is the amount in grams present in 1000 cm cube. So I will just say X gram is present in 1000 centimeter cube. So when I cross multiply, alright, I'm going to have 1.04 times 1000 is equals to 500x. Divide both sides by 500. I'm going to have 2. So I will have my x is going to be 2 multiplied by this. That will be 2.08. So my x is 2.08 gram per dm cube. That is the mass concentration of this acid. But I cannot use this mass concentration for my calculation. And that's why the first question says calculate the concentration of A in mole per dm cube. So I'm going to have to convert this to mole per dm cube using the equation 3. And that equation 3 says molar concentration is equals to mass concentration over molar mass. And this is the mass concentration that I've calculated, which is 2.08. I will divide it by the molar mass. What is the molar mass of HCl? Our HCl, hydrogen is 1, chlorine is 35.5. So that will be 36.5. So I'll divide it by 36.5. So if you divide 2.08, you divide it by 36.5, the molar concentration is going to be 0.056. Alright? Mole per dm cube. Alright, so that is the molar concentration of our acid. You remember we had to first calculate the mass concentration, okay, grams per dm cube. Alright, and then we converted it to yes. From mass concentration, we converted to concentration of B in mole per dm cube. So we are going to be dealing with the concentration of base. So here my Ca is 0.056 mole per dm cube. Now we are looking for Cb. So let's wipe this side. So the question says concentration of B in mole per dm cube. the formula CAV over CBVB equals to NA over NB. That is what we would use. So we are looking for CB. So you have CAVANB equals to CBVB NA. Divide both sides by VBNA, VBNA. So the CB will be what? CAVANB over VB. And that's going to be what is our CA? So our CA is 0.056 multiplied by the volume of acid is your average titer value 24.9 multiplied by what is our NB? Our NB is 1 all over what is our VB? Volume of pipette, that is the base 25 times our NA is 2. Alright, so our CB, so if you punch this in your calculator, 0.056 times 24.9, yes, times 1 divided by 25, your answer will be 0.0278 mole per dm cube. So you have been able to answer the second question that says concentration of B in mole per dm cube, or approximately 0.028. So you can do 3 decimal places. If you do 3 decimal places, 1, 2, 3, so it will be 0.028 mole per dm cube, okay? For 3 decimal places. Solubility of sodium transcarbonate in mole per dm cube. Now note, solubility is also the concentration of a substance. So if they ask you to calculate the solubility of a substance, they're asking you the concentration of that substance. Okay? Now, but before we proceed, in the initial question, we were told that 50 cm cube of the acid, okay, 50 cm cube of this substance was made up to 1000 cm cube. So that means this is the concentrated one. When you now added water to dilute, we now have this. So this can be taken to be our V1. So for this substance, our V1 is 50 cm cube. Our V2 is 1000 cm cube. Then our C1, which is the concentration of the base after the titration. So from our titration, we discovered that concentration of our B is 0.028. So that is what we are going to be using here. So the initial concentration it was 0.028. But when they are now asking us for the solubility, they are asking you for C2. So that's what you calculate. So the dilution theory, there are a couple of ways you can answer this, but one of the simplest ways is use the dilution formula. And the dilution theory is C1V1 equals C2V2. So you are looking for C2, which is the new concentration. You divide both sides by V2. So if you divide by V2, your C2 is going to be C1V1 over V2. So let's impute those values very quickly. So if we impute those values, our C2 is going to be, what is our C1? 0.028. What is our V1 times 50 divided by 1000? So the final C2, the new concentration, is now going to be 0.00142. That is the solubility. Alright, in mole per dm. The volume of CO2 that will be liberated from 1 dm cube of B if the titration were carried out at STP. The volume of CO2 that will be liberated from 1 dm cube of B. So look at it. From the balanced equation, these are CO2. From this balanced equation, 1 mole of this liberates 1 mole of this. So can you see this is 1 here? 1 is invisible. So 1 mole here. How many CO2 do we have? It's also 1 mole. So to answer this question 4, asking us for the volume of CO2. So volume of CO2 liberated is going to be what? So you now say since 1 mole of Na2CO3 liberates 1 mole of CO2, therefore, How many mole of Na2CO3 did we have in the calculation? We can get that mole from the molar concentration of our base, which is Cb. And the molar concentration of our base is 0.028 mole per dm³. So that means 0.028 moles of this. We also give 0.028 moles of CO2. But according to at STP, Avogadro's law, it says at STP, 1 mole of a gaseous substance has a volume of 22.4 dm³. So in 1 mole of a substance, including CO2, so 1 mole of CO2 has 22.4 dm³. What will be the volume of 0.028 moles of this CO2? So you just input your 0.028 here, mole, and you equal x. So you cross multiply. So by the time we cross multiply, our x is going to be 22.4 multiplied by 0.028. And our final answer, so by the time you multiply 22.4 times 0.028, the final answer is going to be 0.64 dm³. That is the volume of CO2 that was liberated. Understand everything we have done. What I want to encourage you to do is you go through this video again and again, over and over again, so that you can understand everything we have done here. And when you get to your exam hall, you wouldn't have any problems at all. My name is Coach Paul. If you have not subscribed to this channel, I want to believe you got value from this channel. So please, if you have not subscribed to this channel, hit the subscribe button right now. Hit the subscribe button right now, and do well to share this video with your friends. If you have gotten value from everything we have discussed, go to the comment section and type value, value, value. Finally, before I go, I want you to just state, go to the comment section and state which of the 3 formulas that you think you can easily recall.